Hey everyone, welcome back. In today's session, we will deep dive onto Docker and Docker containers in a microservice based architecture. So let's get started.
So before even understanding about Docker, let me give you a story, and then now let's move on to the Docker. Okay. So first of all, why the evolution of Docker was there, which was exist. Okay. Before even coming discussing about Docker, there are use cases like in the olden days or the traditional days, the applications are built in the form of monolithic architecture. Okay. So what is the monolithic architecture? So it basically ensures that you write all your application code, bundle them, and deploy that into a server. Okay, so on a physical server. Okay, so what happens is everything looks good, the application works fine, and that gets deployed on the server. You have a physical machine. You have to take care of your installation of your application code, your dependencies, and then softwares which are really required to run or boot up your server. Everything you have to take care and then deploy it. But the problem is, let's say if you make some changes on your application code, the moment you rebuild it, again the all the code related changes will be rebuilt along with your server installation commands. Okay, for example, you install some Java. The moment you change something and redeploy it, again it gets installed the Java. Okay, so we don't want that repetition process, right? So to avoid that, later point of time they introduce something like virtual machines. Okay, so what virtual machines does is it kind of gives an isolation to run your applications in different environments. Like on the same operating system, you have something like hypervisor, which basically allows hypervisor in the sense, for the example is VirtualBox, right? So which will allow you to boot up different kind of operating systems on the same existing host machine, so that you can run your application in a Windows based machines or maybe a Linux based operating systems, so you can install on top of hypervisor. That is good. That will actually solves the problem of, at least for some extent, that you are isolating all your application code and deploying it somewhere. But the problem is, which is heavyweight, because you're installing a complete operating system on top of an hypervisor. So the resource utilization will be very high. Even the hypervisor manages the CPU and memory, but your application dependencies and all those will consume a lot of resources behind the scene. Okay, so what they thought is like, instead of even using virtual machines to run your applications and isolate them, uh, they have created or invented a Docker. Okay, so the Docker purpose is not like having a complete operating system installed on top of your OS. There should be a Docker engine which is installed on your OS that will take care of complete isolation of your application code, libraries, dependencies, everything in an isolated networks. Okay, under the hood they already share the same OS level, uh, resource utilization. Okay, so that means every container still use your host operating system kernel details, but what they'll do is they'll not be consuming much more, kind of much more resources like CPU or memory. Okay, so that's what the evolution happened. So from physical servers to virtual machines and then to the Docker. So these applications run in the form of containers. Okay, so everything Docker makes sure that it runs in the form of container. So it is a lightweight process which runs inside your Docker engine, on top of Docker engine, and it utilizes less amount of libraries or application code, which will not require a complete host operating system resources. Okay, but imagine, let's say, as I told you, the traditional days, monolithic applications, the moment you change something, you have to redeploy, everything is fine. But in the case of microservices architecture, the modern applications are built on microservices architecture. That means there is some change in application code of a payment service, then you don't need to touch a customer service related application. Okay, that means, for example, if you take a Uber or an Ola as an example, so they have the application built on a different programming languages. Okay, so Uber might have built its payment service on Node.js, its customer service on Python, its front end facing mapping service on some other programming language. So they have different services built on different languages. Okay, on different environments. So if you make some changes on one of the payment service, you don't need to rebuild everything on the customer service, right? So whatever the change you are making at the payment level, only that change you can rebuild it and deploy it. So microservices basically allows that kind of flexibility to separate every service in detail, and then you redeploy those components in the form of containers. Okay, so all the modern applications uses containerization because those are lightweight and they just require the application or libraries to boot up, and then it gets installed automatically the moment you run your application code in the form of you build a Docker image. Actually, Docker image is set of instructions which you write in a Docker file, and that takes your application code and environment as a copy, and then that builds it. Okay, so it is a immutable object. That means it is a read-only file. You cannot change anything. But if you wanted to run that image as an instance, then the running of an image is called as container. Okay, so that is a higher level overview or a story of the evolution of Docker and virtual machines and all those stuff. But if you take an example image, you understand clearly here. I have taken example here of an image of virtual machines and containers. Now you can see that the infrastructure is there. That means your hardware.
Share your
Vijay,
screen.
You're not seeing it? Okay, I'm sorry.
yes, your screen is not visible.
Sorry, 1 second.
Vijay,
Can you say?
one more thing.
Yes.
You said like that Docker file is not is only readable. It cannot be changed,
Not
right?
Docker file, Docker image.
Docker image, sorry.
Yes. So
Okay,
if you
so it
want,
can only be run.
yes, Docker image is an immutable. So that means the image that you're creating out of a Docker file is an immutable. But if
Okay,
you wanted to run no, that particular image, you create it as a container.
okay.
So that means once a Docker image is built, it cannot be modified. I mean, that is what the immutability is. Okay. If any changes are required, a new image must be created from the desired modifications. Okay. So from your Docker file, you make changes and you rebuild, but the already created image is immutable. You cannot update that. That is what the image is immutability purpose. Okay. Right. So now you can see one example here, which is related to Docker virtual machines and containers. You can see that, right? So there is infrastructure. Okay, you can see my mouse movement right on the page.
Yes.
Okay, so there is a underhood infrastructure, and there is underhood infrastructure for containers, which is nothing but your host operating system. On top of that, you have an hypervisor installed, which is same as your virtual box. And on top of that, you install different operating systems. As I told you, this is how virtual machines looks. So you have your guest operating system. It is a Windows, Ubuntu, Linux, CentOS, whatever it is. And then on top of that, you have your application code as well as libraries related to that. So what happens is this hypervisor manages the CPU and memory and allocation for that guest operating systems. So while creating this guest OS, you can choose how much CPU you need, how much RAM you need to allocate for the guest operating system. Okay, but in the case of containers, again it uses the underlying hardware and operating system, but there is a container engine which you will be installing it on top of your system, which takes application and binaries, not guest operating system. So the guest operating system utilizes a huge resource, which we are avoiding it in the form of in the case of containers. Okay, so that gives you an additional flexibility. Those becomes lightweight, and which will give you a kind of speed up process. Okay, and of course they are portable because you build once and you run anywhere. Like you can run in the local staging or prod or cloud, wherever you wanted to run, you can run it these containers. Okay, you got the idea, right? So you can think of it like VM is nothing but an entire house, okay, with its own kitchen, bathroom, and walls, etc. And container is like flat in the apartment, okay, it's a kind of shared infrastructure, but it is completely isolated, okay. So every both of them have their own advantages, right? Because virtual machines gives kind of more security, because at the operating system level you will be having a more security. The security will be tightened there. But the container engine is lightweight and flexible. For modern applications like microservices, the container engine is really required. Okay, got the idea, right? So
Yes.
now I have created today morning I have created one repository in our same GitHub, Docker concepts, and I have added just a dummy folders dev01, dev02 and readme file. Okay, so I'll be giving the same link after the session so that you can locate it. But every tool that we are adding it, everything I'll be pushing into the GitHub. Okay, so the Git concepts we will be using it until the end of all our sessions, because Docker pull, Git pull, Git push, and all those stuff we will be using on daily basis to make the changes that we are making. Everything will be pushing it there. Okay. So now I have opened the same in VS Code, and yes.
Vijay, one query. So, is it required to gather the information of the multi-tier architecture of the application related to Docker, something like that?
Required to
We
gather.
have because we have different layers of images, right, in the
Right,
Docker.
right.
So, do we need to cover those concepts also? Or is it
Of
fine to
course,
leave them?
I'll be talking about Docker layers as well.
Okay, okay,
Yeah, I'm just giving you a fresher kind of understanding from the
okay,
boot
okay.
up. I'll be
We,
taking you. Okay.
okay, okay. Vijay, the problem is that I'm clear, pretty much clear about the Docker. That Docker are lightweight. Docker can run okay easily. They have their own networking setup. Okay,
Mm-hmm.
but the thing is, matlab, I can't. What should I say? Matlab, I can't visualize Docker. Matlab, why it is using? Why we are using it?
Right,
Matlab, what is the problem it is fixing in our production system? So
right.
that is the problem. Well, I'm learning Docker from almost 3 years, 4 years. Okay,
Mm-hmm.
so it is up to the reading level only.
Okay. So
So that is
you
yes,
didn't understood behind the scene how it works, right?
yes. For the
Okay.
definition part, I'm already clear.
Right. The lightweight and all the stuff, yeah, that is straightforward textbook
Yes,
definitions. But the thing is,
yes, correct, correct.
what happens in the previous days is, let's say as a traditional approach, if you are packaging everything, application code, bundling everything, you run on the server, physical one server, that works fine. But in the long run, like let's say for example, if you deploy the same application in another server, which will
It will
not
not
might
work.
work, yeah, because
Yes.
the problem is the operating system may be different, the application no, the
Language.
language, programming language installed on the system may be different, or maybe the versions mismatch. So those all are the different issues which will cause the application not able to run it. Okay, so the Docker, because Docker will basically help in the process to bundle everything, your application, your OS environment, along with your libraries, dependencies, everything. Okay, so as you have OS environment also included in your Docker, right, Docker image, you put this image anywhere in the world. Okay, that means you put this on a container, you put this on a virtual machine, or you put this on a AWS EC2 instance. Wherever you run that image, it will run exactly same, because all are bundled in a single package. Okay, everything is bundled, your application code, your OS, everything is bundled. So you run in different operating systems, it will work, because you packaged everything, right? So that is what the official Docker definition says. The Docker is used to package, develop, and containerize the applications, and makes easy for shipping the process. Like that means you can put this application anywhere across any kind of operating system. Okay, got the idea, right?
Yes.
So why I'm writing these notes is, whenever you look, if you're attending for any interviews, you don't need to search in the internet what is everything. Okay, what is Docker related, all the notes. Okay, just if you look at this GitHub notes of any kind of topic that I'm explaining, that is more than sufficient. to go and attend your interview. Okay, if you're attending for any interviews, just check these notes before joining that call, so that you will have some idea. Okay, I am not writing very detailed way here because at least I'm giving you an overview. Okay, let's say if somebody is asked what is a container, just tell that it's a running instance of an image. That gives you more kind of idea for them. Okay, because you are not a fresher. Okay. If you feel that you don't want it kind of notes, let me know so that I can directly jump into the writing Docker files and all those stuff. But this will helpful only in the case of when you're looking revising something immediately. Okay. So I have written here image container Docker file registry. So the image is nothing but a blueprint or a template, like an ISO file. When let's say if you're using a virtual box, you download a ISO file of operating system and then you boot that as a guest operating system in virtual box, right? Have you ever done that? Installing a virtual box and
Yes,
installed
Vijay.
right?
Yes,
So
Vijay. It's a
that
big file.
Yes, yes.
Hmm.
so that is exactly the image. And the container is a running instance of image, okay, which is like a VM running from the ISO file, okay. And Docker file is a recipe to build images. That means set of instructions that will be present in that file, and that file will make sure to build an image, okay.
So Vijay, from where we will download the ISO file for the Docker? From the Docker Hub.
We are not downloading ISO. ISO file is used to boot up your guest operating systems in the VM standpoint. That means
Okay.
if, for virtual
You
machines
are
in the virtual box.
you're giving the reference of the VM.
Yeah, I'm just telling you that this is how, in the case of VM's ISO file, you will be downloading it, right? So that's a reference that I'm showing you here. Okay. We are not for Docker. Will not be using any kind of ISO files. Okay. So you can store your Docker images that you build. Okay, or you can also pull the images which are already exist from Docker Hub. Okay, or ECR, GCR, etc. Okay, so you can
For the Azure services, what it is called? For the ECR is for the Amazon
there is some
Elastic
service
Container
name, I
Registry.
think. Sorry.
Okay, okay, we will check.
Yeah.
Yes,
What is that?
registry, right? Registry. Okay.
Registry service or something like that. It kind of
Something,
the same
something I
service.
just remember.
Kind of same service name only, but the purpose is same. Okay. They act as like storing your images and pulling the images from there. Okay. So you if you compare with GitHub, GitHub is like a same as Docker Hub. Okay, where GitHub you clone the repositories, from the Docker Hub you pull the images, and the images that you create locally you will be pushing it to the Docker Hub. The code that you are writing it in a local, you will be pushing it to the GitHub. Okay, kind of similar thing. Okay, so if you wanted to visualize, this is how it looks like. The source code, from the source code to create a Docker file. Okay, and then using that Docker file you generate an image or create an image or build an image. Okay, and once the image is built, you push that to the registry. Okay, and you can run that as a container. Okay, so this is usually the process. Okay, so whatever the application code that you have, you dockerize that using a Docker file, and once the file is ready you build that as an image. Okay, the image can be run locally. Once the image is run, you get a container, but image can also be pushed onto the registry. Okay, and you can,
So,
yes,
so Vijay, a running instance of the image is called the container, right?
right, you can see here container
Okay,
running instance of
and because I always get confused during the interview that what is Docker file and what is the Docker image.
that is why I'm
So
writing it here. Just in a very
yes,
short form, I'm writing it here. Container is running instance of image. Image
so
is a blueprint. Yes.
okay, okay. So Vijay, as per the definitions, right, like the Docker file. Okay, so we all have read like a set of instructions. Okay, so what are those instructions written in the Docker file? Okay,
Right.
that is. my confusing part.
Right now, I'll be writing that only in the next
Yes.
in a
Yes.
minute or two. Okay. So I understand your confusion, but
I'm sorry to bother you,
no
but
problem.
I'm yes, yes,
Just bear with me for yeah,
sure,
as
sure.
we have another half an hour, so I'll be discussing in detail about them. But I'm just giving you a touch upon the fundamentals. Once you understand this, then whatever I write in the Docker file will make more sense. Okay.
Yes, because for the definition part, I'm already clear.
Okay.
But
Good.
for what is happening behind the scenes, that is my confusion part.
Got the idea, right? So now, yeah, before even actually moving on to the Docker side, do you guys already have Docker installed on your system?
No, Vijay.
Okay, so just go to the Docker download page. Okay, and then install Docker Desktop on Windows. Just download this Docker Desktop for Windows and install it. And if it asks for WSL2, which is a Windows subsystem for Linux, okay, if you are running on a Windows, then it will ask you for WSL2 update. Then you open your PowerShell and execute the command WSL2-update, which will actually updates the your operating system with a kind of supporting the Linux environment. Okay, so once that is done, then you can have a Docker desktop installed on your system. Okay, I already have it on my system, so you can see that Docker desktop, which will give you a left side a clear cut understanding what are the containers which exist, images, volumes, builds, whatever you run, everything will be visibility here in the form of Docker desktop. Okay,
Great. Okay.
and yeah, that is your task as well to perform installation process in your operating system. Okay, if you are already having a Linux operating system, or if you wanted to run it on the virtual machine on AWS EC2 instance or Azure virtual machine, just launch that instance of a Linux type operating system, do apt-get update and apt-get install docker.io, and you do a systemctl start docker and enable docker. Okay, that will be very simple compared to Windows installation process. Okay,
So we can download it in Windows as well. Okay.
yeah, now I'm into the Windows system,
It
right?
will
So
not it will not ask anything else like the WSL part.
yeah, that is what. Once the installation is done, you have to restart your system. Once it is restarted, if it asks you for WSL2 update, then you type
Okay.
WSL2 hyphen hyphen update. Okay, on the PowerShell, then it will take care of the installation of WSL2. But if it doesn't ask anything, just use the Docker desktop from there itself. Okay, once it is done, you can do Docker hyphen hyphen version to check what kind of version is installed on your system. Okay, from your PowerShell, right? Clear. But in the Linux, it is very simple. As I told you, just execute those instructions. Okay, which instructions? Your Linux installation. But you can refer that in the notes from the internet. Okay, those are the just three instructions you have to execute. You
Yes, yes.
you have to get
Then Docker
update.
install command.
You have to get
apt
update.
update,
Yeah, apt update,
then
and
Docker
then
install.
yes, and install docker.io, and then systemctl start docker, enable docker, restart docker, or whatever it is. Okay, so that is very simple.
Anas, I'll be helping you with the installation part. You can continue. Okay.
Okay, right. So now once the setup is done, right? So you can use Docker commands. So there are some commands which I'll be listing it here now. Okay, which will check the version and Docker run hello world, for example. Okay, so here hello world is an image. You can run it. Okay, so where is it, the hello world image? By default, it pulls it from the Docker hub if you don't have it. So Docker run will actually run the run command. What it does is it pulls the image and then it runs it. Okay, pulls the image and start the container. Running an image is called container, right? So once it pulls the image, it starts the container. Okay, and then we have some commands like docker ps to check all the running containers, docker ps -a to check stopped containers, docker rmi with image name which will remove image, docker stop container id, docker start container id, docker what is that, pull image name pulls from docker hub, docker push image pushes to docker hub. Of course we need to tag and specify the exact naming convention, but just that is the syntax which usually uses. Pull, push, rmi, remove, start, stop, ps, all these commands are, you should become very flexible because those are all the commands which you use on a regular basis in order to work with docker. Okay, and of course you have docker images command to check all the images, to check available images locally. Okay, and then you use docker logs with container id to check the logs of a container. Okay, and then you can use docker exec command -it interactively with container id or name. Okay, with /bin/bash. Okay, so what it does is it gives you an interactive shell, allows into interactive shell of container. Okay, so if you wanted to go inside the container, the exec command will basically help. Okay, so in real time we will be getting inside the container and see if the code changes were taking any effect or not, or if there are any problems inside the code which was deployed in there. So you use a docker exec. Okay, so the exec command is mostly useful, and of course even in the when I am discussing about Kubernetes, we use kubectl exec as well. Okay, so this is pretty much similar command, so try to use that when you are practicing it as much as possible. Okay, and docker images, logs, ps and all the stuff, this one you got. And then docker system room, which removes all unused containers, volumes, networks, etc. Okay, so it removes everything if you do docker system prune, which removes all the details related to the existing data of docker. Okay, so these are the basic commands you need to remember for sure, docker related commands. Okay, any questions as of now?
No.
Okay, docker login, of course one more command is important, docker login command. This we will be using in CI/CD as well to deploy something onto in the form of docker containers. First you need to authenticate yourself with the docker login, so the docker login is important command. And docker build command, -t, you build an image. In order to build an image from a docker file, you issue this command, docker build -t with an image name which you wanted to call, let's say for example test image, and the docker file location. If the docker file in this path, then you basically mention that as docker file location with image name. Okay, that's how you basically use docker build command. Okay, right, now these are all the different docker instructions we can execute in the from the PowerShell. But now what I'll do is I will go into the day01 folder, and no, I don't really need to go into page 01, but yeah, I'll be this root path and I'll create Docker file now. Okay. Put it here. Okay. So now always remember Docker file should be mention it here. Docker file should be Docker file name should be Docker file name is case sensitive. Okay. Always use uppercase T, like Docker file. Okay. So as we learned that Docker file is nothing but recipe to build the images, right? So it takes our source code, then you write it as a Docker file, then you build the image and then run the container. But Docker file has certain instructions. Okay, so everything will be written in the form of instruction and parameters. Okay, so Docker file is written as instruction and arguments. Okay, so Docker file reference, if you go into the site official documentation, directly it will pull you the commands or the instructions which Docker file takes as an instruction. You can see that it takes in the form of this format, instruction and arguments. So the instruction is not a case sensitive. That means you can write it in a lowercase as well, but always remember that writing it in uppercase will make more sense compared to your arguments. Okay, so these are all the different instructions which are present inside the Docker file. You can use few of them in the Docker file or all of them in the Docker file based on your use cases. But remember, every Docker file basically starts with a from. Okay, so that means that is a base image that you are pulling it in the Docker file. Okay, so from always try to install the Git Docker extensions. Okay, in the VS Code, which will give you some kind of highlighting for you to write in a simple way. But always remember, from is the first one, the key instruction that you will be using it. And let's say I wanted to take the base image. So every Docker file is built on top of the base image. Those base images were already built, and you can take that as a reference and improve your Docker file based on your source code language that you are using it. Okay, so let's say for example, if I take CentOS, okay, colon 8. Okay, so how did I get that actually CentOS? Because you can go into Docker Hub, Docker Hub registry, and then you can find a lot of images which were already present, the official images and some other images. You can search for anything. Okay, if you are working on Nginx, search for Nginx. If you are working on any kind of operating system related like CentOS, search for them. You will be finding official ones, Docker official images. You can check these boxes to filter it out, but that's how you can basically use that base image. Okay, and there will be a different tags here in the quick references down. You can see that the minor tags, some other details. So you can check based on which kind of tag that particular image is using it. Okay, so in my case, I'm thinking to use Docker CentOS colony 8. So what happens now? The instruction has been written. Now I wanted to build this Docker file, right? So how do I do that? As I told you, in order to build it, Docker build -t, the image name with the location of the file. Okay, so in my current folder, I have a Docker file at the same location, so I'm using that and press enter. Okay, so what it happens is, now it will build that as a form of image, as pulling that CentOS operating system, which is not a complete operating system, lightweight process which will gives you to run your application smoothly. Okay, so that is one.
But why you are doing this? Like, no, I'm still in confusion. Like, why you are using Docker file actually?
Oh, you didn't understood the concept of using the Docker file itself?
Not so much. Yeah.
See, if your application code, let's say if you have already application code, you wanted to bundle that application code along with your dependencies, environment, everything, then you
Hmm.
create as a Docker file and build it as an image. Okay, so the Docker file is created to bundle everything about related to your application code so that you can ship or deploy somewhere. Okay,
Hmm.
so you can see I have mentioned here the definition. Dockerfile is a recipe which includes different instructions to build the image.
Build in the sense like you are installing some dependencies.
Yes, that is what in the Dockerfile we will mention. Okay, so each and every instruction performs some activity. Now I have only added one instruction. That's why it was not making a much sense for you. But usually you can add some instructions like run command to install some packages. We can use copy command to copy some data from source to destination. All those instructions will be adding it here. Okay,
Yes.
what's the idea?
So,
Okay.
so Vijay, the first one is from CentOS. That is the base image command, right?
Right.
That you have copied from the Docker.
Right, you're right. So now we have only
Okay.
one instruction. I just build it. Okay, that created a cache layer. So next time, whenever I'm rebuilding it, it will not again pull everything. Okay, it performs immediate. It takes from the cache of the Docker, and it execute that layer. Okay, so every instruction in Docker file is acting as a layer. Okay, so now I have from CentOS colon 8. That is a one instruction. Next I will use work dir. This is another instruction. Okay, so when I say work dir, I am saying that create a directory name called app inside the container. Okay, so the work dir is the working directory which I wanted to create inside the container. Okay, and then you have some other instructions like run instruction. Okay, for example. Okay, and that's why I have opened the Dockerfile reference. So all these commands will be there in the Dockerfile reference page. You can see that now run instruction which executes build commands. Okay, and what I used work dir command as well, right? So work dir, it's changing the working directory, and I have used from command. It creates a new build stage from the base image. Okay, so this reference you can just read it, but now you understand that run is used to execute some instructions inside the container. Okay, while building the image, of course, while building the image, these instructions gets performed. Let's say for example, I wanted to run echo hi there. Okay, and I wanted to put this into a file called message.txt. Okay, so now I have three instructions. Okay, out of three instructions, run will be considered as one instruction, from will be considered as one instruction, work dir which will not be cached. Okay, work dir, env, label, these are also some instructions which will not be as treated as a layers. But now it will rebuild the image. Whenever you wanted to rebuild something, again you execute the same command docker build -t, the image name dot. So what it happens is it again takes the CentOS image and it performs echo command hi there, and it stores this data inside message.txt file. Okay, so how can we see that this is inside the container? Okay, as I told you, the work dir will create a directory inside the container, so this content will be put it inside the container message.txt. Okay, if you wanted to know that, then you have to run this docker file. That means the image you have to run. Okay, running an image is called container. Okay, so now if I do docker ps, I don't have currently any running containers, but I will be running it now. Docker run, what is the image name? We called it as test, right? So this is how I'll be running docker run test. What it happens is it will run the container of test. Okay, it will create this hi there, and then this slash app dot message.txt file will be placed in that particular inside the container. Okay, so in order to see that, what I can do is docker run -it interactively test /bin/bash. So what I'm saying is I wanted to get inside the running container. Okay, now I am into the inside the container of that particular test image, and I will be seeing whether the message.txt file is created or not. So I will go to /app ls. Now cat message.txt. You can see that hi there is it. You got the idea? Any questions?
Hey, what is that IT interaction mode? What is that?
Interactive terminal. So docker run -it will allows you to have an interactive terminal. Let's say if I don't do it, right? I'll show you the difference. If I don't do it, docker run test, if I do that, what happens is it already ran and finished. Okay, you don't know what happened actually. If you wanted to see whether actually it has run or not, just do docker ps-a. You can see that the container was already exited 9 seconds ago. It has ran the initial command /bin bash. That means by default the CentOS image uses the cmd instruction which is called /bin bash. That means a shell was opened and closed it automatically. Okay, that's why if you wanted to get inside and see, then you have to supply /it field along with your image name. So this will allow you to go inside the container and see what is there. If you don't supply that, the container ran and exited already. Clear?
Okay.
If let's say for example I wanted to see docker run test and I wanted to see whether what is the working directory. Right now we set it as app, right? But whether that is really using it or not, if you wanted to see, execute pwt. Okay, you can see that pwt now it has created /app and exited. So the container purpose of the container is not like a VM. Okay, VM will actually waits until your operation is completed, and once you turn it off, then the VM will get shut down. But in the containers, it is not like that. Once you tell that something you have to run it, it will run it and it will automatically exit. Okay, so that is why if you don't want it to see that as exit, you supply that -it. Okay, so that you can go inside the container and perform some activity. If you don't supply that, it will do its task and then it automatically terminates it or shut down it. Clear? So VMs are like you will be powering off, you will be shutting down manually, but containers are not like that. That's why it is very fast and lightweight, because it does its task and then exits out. Okay, so now we understood from instruction, work dir, run instruction. Now we can also do something like copy something readme.md into dot. Okay, so what it does is now you're taking the readme file, which is same location of the docker file in the same area, this readme.md, and putting inside dot folder. Dot folder in the sense, this is a source area, this is the destination area, right? So inside the destination, what is our destination? Inside the container, app is the destination, correct? We have seen it, right, already. The pwd is printing /app. So I am saying that copy this readme file and put it into the /app folder. Okay, once it is done, we can see what is the content which is there in this, whether the file has been copied or not. So now we made some changes in the docker file. Whenever you make some changes in the docker file, you always need to rebuild the image. Okay, again you do docker build -t, the image name, press dot. So you make some changes in docker file, you should build the image to take effect, otherwise it will not take any effect. Okay, now the build image has been done. Now you can see that it has 1/4 layers, 1 2 3 4 layers. Now it cached already work dir, it cached already this previous commands. So those are already done and it is getting it from the cache. But the new one, copy readme.md, this is actually built now. Okay, now what we can do is we can see whether that particular file is there or not. Docker run -it test /bin /bash. Okay, now I am inside the container, and if I see ls, message.txt is there, but readme.md is not there, but it is where it was copied, /root docker run -it test bin bash. Okay, docker ps-a. Okay, let me exit out and rerun it once again. Docker ps, you're understanding, right, what I'm trying to do?
Yes, you're finding that in the README that it's
The
copy or
file,
not.
yes, the current file which is there, readme.md, but
It's
maybe
copy
it
to
is
app or not.
right, maybe it is not detecting the file path, readme.md. That's why it is not storing the content. Let me do one thing. Instead of readme.md, just do dot. Okay, that means take everything from the current location. Okay, take everything from the current location and then put it into the app folder. Okay, so docker
What is
p
the current location?
dot, this is the source. The copy instruction takes in this form. Okay, copy
Source and destination understood. Like from where it is copying. Like you can say in the Docker file there is a readme only copy to app, right?
See, Docker sessions is the folder. It has two
Yes,
folders along with
yes,
two files. Okay, now
yes.
if you see here also, if I do ls, now you can see that I have day 01, day 02 as well as readme file. These files are there,
Hmm.
right? Now I am saying that the moment you build it, take all the files from the current path and put it inside the container. Okay,
Okay.
slash app slash whatever it is. Okay, just you don't need actually slash app slash also, because the moment you set the work directory as slash app, all the instructions that you are running in the next will do in the slash app folder itself. Okay, whatever you write many instructions here, all those will take place in the slash app directory itself. Okay,
Like in the dot means copy, dot means source destinations, right?
yes, the source
And
is, yes, source is nothing but all the files.
all the files, and destination means that
Destination
app
is app
working
folder,
directly. Okay,
right?
okay.
You can mention specifically the slash app path, but it's not really required. Okay, so now what I can do is docker build -t test dot. So I'm rebuilding the image again. The image has been built. Docker images. I have the image, test image. Okay, previously I used to call it as image. Okay, okay, that was a mistake. Docker so docker images, test is there. Now docker run -it test /bin /bash. Now we are in the interactive folder. Now you can see that all the files got copied. So docker file readme.md day 01, day 02 message.txt. So why the message.txt? Because in the run command we are already saying that slash app message.txt, create this file as part of the run instruction, right? So that's why it has created that message.txt file. Okay, if you wanted to come out of it, just press exit. Okay, so this is how you write different instructions in the docker file. But not only from workdir run and copy, you also have some other instructions like expose. Okay, so expose is kind of application port number. Okay, it
Okay, that test. Yeah, while building, you are writing the test, right? That is what is that actually?
sorry, which one?
While building that file, so you are using a test, right? Last
Okay, that is the image name. Okay, docker
image name, right?
build -t tagging with an image name. So you can call it as any name. Okay,
Any name, right? Okay, okay,
yeah,
okay.
DevOps. I can call it as DevOps and then build it. Okay, whatever the name you wanted to build, call it as that is the image name. Okay. So expose is also one of the other instruction you wanted to execute. So this will, what it allows is, it will allows to expose the port of your application. Okay. So let's say if my application is running on port 5000 or 3000, I can put that as expose 3000. So whenever the container is running, it will expose that as form of port 3000 or i5000, whatever it is. Okay. And if you wanted to supply some environment variables for your application, do with data is equal to key and value, data equal to 1 2 3. Okay, if you wanted to supply multiple environment variables, you can use env again, but instead of rewriting or repeatedly writing the same env, you can just pass slash backslash and say xyz is equal to abc. Okay, so what it does is, whenever the container is built, whenever the container is ran, the env instructions, right, the whichever the data you have passed, that will be showed as environment variables. Okay, now I will show that. Now I will do docker build -t test dot. So what happens is it will again do the same kind of caching and same kind of copying the files, everything. It exposes the port, it creates this environment variables, everything it does. All right, now you can see that 4x4 copy and all the stuff it was done. Now if I do docker run -it test /bin/bash, okay, now I'm inside the container. Then now if I do ls, I have this all the files data, right? I will exit now, okay, and I wanted to see whether the environment variables we got created which are really exist in the container or not, okay. So I can do something like docker run test env, okay. So now you can see that the moment I run the docker run test with the instruction, the container has run and exited out, because we are no longer using -it to get the interactive shell. We are just running directly, so the container performed its task and exited automatically. Okay, now in the env you can see that xyz abc is there, data 123 is there. So whatever the environment variables we configured, these variables were already exist inside the container. Clear?
But what is that Docker run -it? That is fine. How you know that like it is existing the /bin or /bash?
That is what, if you do docker run test, okay, and press
Mm-hmm.
enter, what happens is the container has ran and exited. Now if you
Yeah.
see, if you wanted to see whether it is really ran or not, docker ps-a, this will show you the details, but you can see there is a command called /bin/bash, okay. So
Okay.
by default CentOS uses a cmd instruction, which is a shell. /bin/bash indicates a shell which was opened
Mm.
just, and it doesn't know what to do and just it closed it, okay. So by
This is
default,
by default, right?
right, so we can override that by adding our own cmd instruction. Now I will be adding another instruction called cmd, which takes two parameters. One is executable, the other one is parameter, okay, echo hi, okay. So now what it does is executable and params, okay. You can pass multiple params for this command cmd. Now what we are saying is, hey, the moment you run docker run test, instead of just opening the shell and exiting it out, you display the hi message for me, okay. That is the overriding behavior I'm doing it now, okay. Previously you asked the moment it ran test why it is exited, because it was opening a shell and it don't know what to do, then exited. But now we have overrided already existing docker. See, every base image has its own cmd instruction. The CentOS has default cmd instruction, that is this one. Now we are overriding with our hi message, okay.
Okay.
So to see that in effect, again you build it, docker build the image. So the building will be very fast, because it will execute the cmd instruction. And then now docker run test. So what it will play, what it will do, previously it was just exiting out, right, without doing anything.
Mm.
But in our case now it will print hi, you can see that, because we are
Okay.
overrided the behavior of default shell opening /bin/bash. Now what we can do is, we can also pass our own arguments for the cmd instruction while running the container also. That means docker run test, I will say echo hello, okay. So what it does is, now instead of executing hi, it
Why
will,
it's a hello.
it says
Mm.
the hello. So I'm passing this as an additional parameter to the running image, so it will override that behavior, okay. So that
That
is,
is fine, but I'm still wondering like how this will help in packaging this. How it is helping to containerize. I don't understand this. Like
how it is helping in the form of
for
contain.
any application, for example, if you have any application
Yes,
and you want to containerize, so
right, right.
how it
So
is doing it? I'm with the help of this from directory, like how
right,
this working. I can't understand this.
right, now I will show you uh, in the real time. If you have an source code, right, so you take for example python, okay, python 3.11 or whatever it is, okay. So what it does is you set the work directory, okay, /app. You copy your requirements.txt into /app folder, okay.
Mm.
You copy the file. Requirements is nothing but your dependencies, your application dependencies, okay.
Okay, okay.
So what I can do is I can create a requirements.txt file, okay. I can put it here, requirements.txt, and it has some Flask, it has some pandas, some libraries, okay, whatever it is, okay. So whatever the
Okay.
libraries you wanted to install, you put it as inside the requirements.txt, and
Mm-hmm.
then you use a run command to execute that pip install -r requirements.txt, which will install the packages inside the container, okay. And then you copy the source code, okay, copy everything into /app/folder,
Mm-hmm.
and then you expose the port 5000. Let's say Flask is running on 5000. Then you use cmd instruction like python app.py, okay. So this is our real-time application docker file looks like, okay. It takes app.py file, okay. Let's say if you have already app.py file in the same folder, okay, app.py, I will just move it here. App.py has some content, print hello world, something like that, right? So
Mm-hmm.
what it does is, now the docker file which we written, it creates a /app folder, it copies the requirement file into the /app folder, it installs the package dependencies, it copies all the code. The dot means it copies remaining all the files. In our real time use case, we have a bunch of code files, right? But
Mm-hmm.
now in our case, we wanted to copy app as well, so I'm just using dot to copy everything and put it in app folder. Expose that particular application. Let's say if the Flask application is running on port 5000 or 3000, you expose that as a 5000, and then cmd python app.py. So that means the instruction, whenever the application is run, it automatically executes that whatever the content is there in that particular application, correct? In previous case, we run echo hi, right? The moment
Mm-hmm.
you run docker run test, it was automatically printed hi in our console. But in
Mm-hmm.
real time, it will run the application, okay, not just printing something, okay. So let's say the app also, I will also do app.py. Let me take a sample Flask code, okay, so that you will have a Flask hello world code, okay. So it will give you a Flask hello world sample code to run. This is the one, okay, for container, okay. I got this code. You can use any kind of code, Java, .NET, Node.js, whatever it is, okay. Just put that code here, okay. Okay, now what I'm doing is, if you read this code, it is just bringing the library of Flask, and then it's setting a path slash, and then it is printing hello world. So what it does is, the moment you run the application, right, it will run on a port 5000 on an open host 0.0.0. That means on any IP address or any system with a port 5000 open. The moment you hit that local host colon 5000, it will give you hello world, okay. That is what it simply the API endpoint is doing, okay. Now in our docker file, we added all the instructions, we passed the requirements.txt, we installed the requirements, we copied the code, we exposed the code, we run the application as well, okay. So now if I build it, docker build -t flask app dot, okay. Now we are actually building our source code. Instead of just writing dummy data, I'm actually building the application code, bundle that everything in the form of an image. Then it was failed to build because failed to calculate checksum of this requirements.txt not found, okay. Oh, I didn't spell it correctly.
Requirements.
Spelling, yeah, UQUIREMENTS, okay, REMENTS, okay, the spelling mistake, okay. Just rebuild it again. So now what it is doing is it is taking the base image, it is copying source code, it is installing the packages, it is exposing the application, and then it is automatically running the image. So I running the application. So the moment you package everything in the form of image, this image you can run in the form of container anywhere. Okay, I can take this image and deploy it on EC2 instance. I can take this image and deploy it on Kubernetes clusters. Okay, so you think like this is a front end application, there may be a back end application, there may be a database application, there may be a payment related service. All are different images, they will be running individually. So if you make some changes in that particular code, let's say if you feel that this application is not working, you build that only this particular image, not everything whole, right? So that is why Docker will containerize everything in the form of images, and then you can basically run that anywhere. Okay, so now it is building. Let's see in action what
Okay, go
happens.
to once can you go to Dockerfile once?
Yes.
Dockerfile. From Python working directory app, you have created a new working directory and you're copying the requirements from requirements. Okay, requirements to directly app. You are installing some dependencies,
Uh,
then install again installing some dependencies also, right? Okay,
yes.
installing. Again, you
Yes.
are copying everything to the app. Everything in the sense this require
Requirements
which are
also. So that is a good question. Actually, everybody will get doubt here. Why? Because the moment you do /app, which automatically copies requirements.txt, then why we are mentioning again this requirements.txt as a special command? Correct? That is your question,
mm,
right? So the problem here is Docker will use form of caches, right? Caching layers. So every layer is pre-built if you make any changes. Okay. So the requirements.txt file, let's say this requirements.txt file won't be changed always. Only you will be changing majorly your code, right? So the requirements.txt will be changed very rarely. That's why we are using that as a separate instruction. If you don't do that, what happens is if you can see I can comment this line and just use this one also, it will work same way. But the problem is if it will install every time the same package. So the moment you are building it, it will take, now you can see that it is taking some time to install, right? So always that process will be takes place more and more. It will consume more time for the build process. So if you mention that this is an external instruction, what happens is once it is built, it will be cached. Next time when you are rebuilding it, it will not install the Flask again because Flask is already there.
only
Just
requirement. Okay.
only the changes inside the code will be takes place. That is why I'm adding as an extra layer. Okay.
Okay, that is fine. But another thing is copy dot app. You're copying everything, everything in the sense what you're copying. Like again,
Yeah,
day one
in real
question.
time you will be copying
But you did
everything.
not explain that specific if you want to copy
You
something.
can, yeah, if you wanted to add, you can add only the app.py. See,
Okay,
specifically I
okay,
can
okay.
mention app.py to copy, but in real time you will not mention only one file. You will mention all the files of your bundle and put in the app directory. Correct.
Okay, okay,
So
okay.
that's why
Yeah,
I'm
yeah.
using that notation. But in our case, these are all dummy files. We don't really need all them. We need only app and our requirements file only, right?
Mm-hmm.
I can mention directly app.py here, no problem. Okay.
So this is the standard template, right? Like from work dir, copy run, copy expose CMD.
Right. This is a standard instruction you will be following for any kind of application, Java, .NET, Node.js, whatever it is. Okay. But
But
there may be a
somewhere I think
different.
we need to understand code also.
Yes,
Somewhere I
you need
think
to understand which language use which kind of files. Let's say Java use pom.xml, .NET use something, Node.js use something, right? So those file dependency file names, how you understand how to run those instructions are enough. The remaining stuff
that
is
is fine.
pretty much.
Like in the interview point of time, I think they may ask some coding also because I think we need to understand code also
They
bit.
will ask you to write a Docker file. Of course, they will ask you to write some Docker file instructions. So you can write a simple Docker file instruction. You don't need to write code-based instruction. You can write this one like this. So what are the different
Okay, okay.
work DA? You can show them that copy will do this stuff, expose will do this stuff. We can add environment variables like this. We can do CMD instruction like that. So you can
Mm-hmm.
explain them by writing the Docker file. Okay.
Okay.
Now we got the image built. If you wanted to see if you wanted to see that whether the image is built or not, Docker images, just run Docker images. You can see that Flask app. Okay, so now we will be running it. Docker run hyphen it I don't want it to get inside that actually. Docker run -d -p 5000 colon 5000 name
Mhm.
test, and then the image name. I can call this as what is the Flask app. So what happened if I'm using this big command, right? So what it is doing is it is running in a detached mode. In the background, the application, the code will run, okay, in the
Yeah.
background in the form of container, and then we are exposing a port on the host machine along with the port which was exposed inside the container. So this is the host port, this is the container port, okay, and we are naming that container as test, okay. So I think test is already there, so let's use this name test1, okay. So we are naming that container as test1, okay, and then the image that we are running is Flask app, okay.
Okay.
So now the image has been ran. It is running actually behind the scene. If you wanted to see Docker PS, you can see that Flask app image is running with a name called test1,
Just one.
okay, and you can see that 5000 5000, okay. So now if I go back to my browser and do localhost colon
2000.
5000, and you can see that hello world is displaying.
Mhm.
Clear? Now if I wanted to make, so let's say for example, if I wanted to make some changes, instead of hello world, I do some hi world, okay, hello world, some gibberish, okay. I had some content more, then what I can do is I can just do docker build again to take that effect Flask app, and then again I will be running a new container, okay. It will not now install all the libraries. Now it was fast, very fast. Previously it took some time, right? But this time it was very fast because already the Flask is installed. It don't install again, it will take from the cache, okay. So now again I will execute docker run port 5000 with 5001, because I will be using different port because the previous application is still running on a port 5000, right? We have not stopped that, so that's why I'm using a different port with a different container name, okay. Now you can see that the two containers are running. Docker PS, two containers are running right now, right? One is 4 seconds ago and about a minute ago. Both are running on a 5000 and 5001. Let me do localhost 5001.
So you're overwriting on it, right? Again.
Yes. So now you can see that two applications are running. The same application is running in different ports with 5000 and 5001 with different content.
Okay. Mm-hmm.
Got the idea, right?
Yeah.
So now if I do docker ps, I have this docker stop will actually stop the container IDs. So I can take these two container IDs at a time and just stop them, okay. So the docker stop will actually stop both the containers. Now if I do docker ps, nothing is there. If I do docker images, I have still the three images are there. Now what I can do is I can docker remove image with a Flask app name, okay, and test image
Why using
and
RMI? That's the RM, right?
RMI remove image is a shortcut, okay.
Okay. Okay.
So unable to desk because it's using a reference image, okay. I can do -f on this particular image, which will forcefully removing all those, okay. So now docker images will do I can remove that image id, remove image with an image id if this is linked to the none, but forcing is important sometimes, yes. Okay, fine. So this is how basically Docker file and Docker instructions. If I do Docker system Docker ps-a, which will show me all the stopped containers. Okay, so these are all the stopped containers. You see that these are all the different names. The moment if you don't put -hyphen name instruction, which will assign a random name. Okay, so to avoid that, I have given test1, test2 as the names. Okay, Docker system prune, which will actually removes everything. Even the stopped containers and all, okay, which will clean up all the space on the system, okay. Now you can see docker ps-a, nothing is there. Docker ps, nothing is there, okay. Clear? Any questions? I know this is a little bit more if you are really new to that, but yeah, that's how it works. Okay. Docker, I will just mention one command here in the notes. Docker run -d -p with the host port colon container port with hyphen name of the container with image name. Okay, this is the command you have to use to run the application. Okay, of a Flask or anything. Okay, it depends upon the application port and all you will be exposing it. But at least you got some idea, right? How Docker files and the different
Vijay, a
instructions.
small doubt. Sorry for this.
Okay.
Something is getting stuck in my mind that when you return Python Docker, go to Docker file.
Sorry, Docker file. Okay.
Yeah. In the when you wrote Python dot 3.11, it means for everything you are giving customized working directory, copy, run, everything customized. But how like taking out from Python dot 3.11, this one how it works?
So that is the Python version of the Python version. Okay, let's say Java has Java 7, Java 3, Java 4, like that, right? So Java has different versions. Python has a Python 2.7, 3.5, 3.6, 3.11 different versions. Okay, right now the current Python version is 3.13. Okay, but I'm taking a 3.11. If you don't want to take it, you can just remove that. It will
So
automatically
anything, right? Anything will work, right?
it will
But how do you
automatically
know
take
that will
us.
be compatible with the browser and all? Because anything you're pulling, right?
Right.
Okay,
So
latest.
yeah, the
Mm-hmm.
latest. If you put as latest, it will take automatically the latest image. If you don't put and if you specify a version, then only the compatible commands related to 3.11 will work. So this is the command which will work for all the versions. Okay. If every Python file you will be calling with Python with a file name. That will work in the Python 2.7, 3.5, 3.6, 3.11, whatever it is. So I'm just randomly taking any kind of
Okay,
tag,
okay.
but you can take a latest as well. Okay, just to latest, it will pull the latest image.
And one thing from Python you are writing, I can write anything. Is that
Yes, of course, you can write Node.js. Okay, Node.js something latest.
is it pulling from the Docker Hub or something?
Yes, of course. By default, Docker desktop basically pulls the images
So
from the
for
Docker.
example, you have a custom something and that is not available in Docker Hub. So how does it work?
That is what Docker images we can pull it from the registry. Okay, so something like
Registry. Okay,
ECR registry or
okay. Okay.
some other registry. In order to do that, you have to authenticate with Docker login command, and you configure that particular endpoint URL, and then you can pull that image from the any kind of hub. Okay, but by
Okay, cool.
default,
I
it
will do
pulls
that
it.
once. I'll
Yes.
try to do once.
Yeah, by default pulls that. So you practice all the instructions which I use now, like CMD, environment, expose, copy, run, work, dir, CMD. All these instructions will be there in the reference file. Okay, so this file you take as a reference and just use the different commands. You can use work, dir, expose, and all. So some of them we have seen. Most of the important stuff we have already seen. So we will
Hmm.
be talking in the next session related to pushing the images and then working with respect to Docker Compose file as well as volumes and networks. Okay. So
Okay.
those are the little bit advanced concepts that we will be touching tomorrow. But now you make sure that you understand, practice, you interact, you execute all these instructions more than 10 times, so that you will have some idea. Okay.
Hmm.
Practice. The more you practice, you will automatically run those commands. Like git pull, you do right very fast. In the same fashion, you do docker pull, docker push, docker stop, docker ps. All those commands are important. Okay.
Thank you very much for being here. With this, we have done the basic understanding about Docker. In the next session, we will go very deeper on understanding about Docker volumes, networks, and Docker Compose files. So I'll see you in the next one. Thank you.